Hi, my name is Ranjith Udawatta. I am a research professor at the Center for Agroforestry and Soil, Environmental and Atmospheric Sciences of School of Natural Resources at University of Missouri. My main research area is to look at conservation practices like agroforestry, cover crops, crop rotation, all these things, how these can benefit water quality and soil quality. As you can see on this background, there is a row of poplar trees, and below that there is a water body. That means before water leaves the grazing area or the crop area, water has to go through the buffer area. Most of the sediment, nitrogen and phosphorus is filtered when water goes through the buffer area. That is what happened on the surface. So we collect surface soil water samples to analyze for sediment, nitrogen, phosphorus to evaluate what is the role of the buffer. So you can say agroforestry buffer is filtering X amount of nitrogen from a crop area, from a grazing area. On my right side, you can see yellow unit. That unit is allowing us to collect water samples from the groundwater. So that unit extends all the way from the surface to the groundwater, about 15 meters. You see, in agroforestry we have trees and shrubs. They have deep root systems. So those roots can remove some of the nitrogen and phosphorus from the groundwater. That's what we are doing with this yellow unit. We are collecting water samples from the groundwater, and down the watershed we have a unit to collect water samples from the surface water. So we are evaluating what are the effects of these tree buffers on surface water and groundwater. That is the water quality part of my research. And we also monitor surface water quality using different types of sensors. How does it change throughout the year? During a sunny day, during a rainy day, during the crop season, when the crop is gone. So that way we can see the role of tree buffers and the crop and grazing on water quality and water quantity. And I am also doing research on soil parameters, like evaluating soil health as influenced by agroforestry. So we collect soil samples from grazing areas, crop areas, cover crops, buffer areas, and evaluate bulk density, infiltration, water holding capacity, and thermal properties. So we collect soil samples from different depths. Then we take those soil samples to the hospital. Like when you go to the hospital, they put you on an X-ray machine and take X-ray scans. So that allows you to see whether there's a fracture or bone disalignment or some unusual things. Similarly, we can evaluate soil cores. When you take soil cores to the hospital X-ray machine, they take X-ray scans. Then we look at the image and see, okay, this soil core has X amount of pore space. Pore means void area, not soil or not water. So that says bulk density is lower. There is more water storage areas. Water can infiltrate much faster. That means when tree buffer areas sampled, they have more roots compared to the crop area, especially in the deep areas. So that means more pores in those cores can be seen in the X-ray machine. And we also take carbon data from these soils. So how much carbon is accumulated in the buffer versus crop area versus grazing area for cover crop area. So similarly, we collect samples to analyze for microbial parameters. We take samples to the lab and look at enzymes, bacteria, actinomycetes, fungi, mycorrhizae, gram plus, gram negative, all kinds of microbial population. That shows buffer area soils have more microbial densities and more diversity. That is, more diversity means they can break down chemicals like herbicides, pesticides, antibiotics. Especially in grazing, you give about, say, 80% of the antibiotics leave the animal and get into the soil or water. So then we can look at when the water goes through the buffer or stays in the soil, how much activity can be there to degrade those toxic compounds like antibiotics, herbicides and pesticides. So those are indications of activity of soil health within the buffer area. So what is the purpose of this research? So we can say, if you establish 10% of the land area under buffers, you can filter X amount of nitrogen, you can remove Y amount of phosphorus, you can retain X amount of sediment in the watershed without losing that topsoil. And at the same time, if you have different kinds of buffer vegetation, you can say, oh, this is a diverse buffer vegetation. It can degrade many antibiotics, many herbicides and pesticides. That means you are improving your water quality and soil quality by applying these conservation practices like agroforestry, cover crops, buffers, upland buffers, and crop rotation on your watershed. That is the purpose of this kind of research that I am conducting at the Center for Agroforestry.